All right, so let's start with the first problem here. We've got to find or solve for k, and there's k right there. So let's get it out of there by distribution. So mx, I don't know why I'm starting so far over to the right. Mx is equal to zp over x plus k plus 2ps over y. And I just multiplied p times the numerator of both of those because this is literally p over 1, right? So now, common denominator is y times x plus k. So I'm going to multiply this by y over y, and this by x plus k over x plus k. And then this is going to be y x plus k over y x plus k, which would then cancel all the denominators. So what I have is m x y times x plus k is equal to zpy, or pyz actually, pies, and 2ps times x plus k. All right, so this is going to be a long one. I'm going to distribute. So mx squared y plus mk xy is equal to pyz plus 2psx plus 2psk. All right. So I'm going to subtract mx squared y from both sides. And I'm going to subtract 2psk from both sides. That cancels that. That cancels that. So I have mk xy minus 2psk is equal to pyz plus 2psx minus mx squared y. Okay, take out my k. mxy minus 2ps. And then all of these, right? Pyz plus 2psx minus mx squared y. So we divide by this to get k by itself. On both sides, which cancels this, which means k is equal to pyz 2psx, and so this would be plus, and this would be minus mx squared y. This would be plus mxy minus 2ps. And I think you can drop the positive signs. I think the only thing that's necessary is the negative signs. But, you know, try it and see. I think that's what makes sense, is to not have the positive signs in there because it's extra. You have to have the negative. You don't have to have the positive. But that would be your solution to this problem. Next problem. Alrighty. Get my pen. Again, m is equal to x over 2p plus 3x squared over b, because I just distributed the x over 1 to the numerators. And we're solving for b. So my common denominator is 2pb. So I need to multiply this times b over b, this times 2p over 2p, and this times 2pb over 1. So 2bpm, I'm pretty sure that's not the right order. All of this would cancel. So this would be bx plus 6x squared p. So now we want to get the b's together. So subtract bx from both sides. This cancels. So 2bpm minus bx equals 6x squared p. B times 2pm minus x is equal to 6x squared p. Divide both sides by 2pm minus x. So then these would cancel. So b is equal to 6x squared p, or 6, probably in alphabetical order is what we need to do. So that'll be 6px squared, and then 2mp, and this would be minus x. And that would be your solution. Next problem. All right, again, distributing the x over 1. So AC is equal to mx over r plus s, and tx over z. Common denominator is z times r plus s. So we multiply everything by that. Z r plus s times AC. This would be z, and this would be r plus s over z r plus s, right? Which we would then multiply by all the denominators, which would then cancel the denominators. So we have 2acr plus 2acs is equal to mxz plus txr plus txs. All right, you want the s terms together, so I'm going to take this one away. That would cancel. And I'm going to take this one away. Both sides. So then what I have is 2acs minus txs is equal to mxz plus txr minus 2acr. So you can see where this is going, right? We take the s out. We get 2ac minus tx is equal to everything on the side. Follows the same pattern every single time, right? Now we're going to divide by this term on both sides. This cancels, so now we have s by itself, and it's equal to this. So that's what we do. We write it in alphabetical order, which would be mxz. This is positive. RTX is alphabetical order. And then we have minus 2ACR. On the bottom, we have 2AC. And then that's minus TX. That would be your solution. Next problem. All right, so again, same process. We're going to distribute. Do not let these subscripted values throw you for a loop. All right, it means that this is a variable and this is a different variable. That's all it means. It is not an exponent. So we have A is equal to x over m to the 1 plus xy over m squared. M1, M2 is your common denominator. So we're going to multiply by M2, M2, M1, 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 M2, M1, M2. So all of this can go away. So we have A, M1, M2 is equal to X, M2 plus X, Y, M1. We're solving for M1. So we want to get all the M1s on this side. So minus XY, M1 minus XY, M1. Okay. A, M1, M2 minus XY, M1 is equal to X, M2. We get the M1s out. That leaves A, M2 minus XY is equal to X, M2. Divide both sides by the other term. A, M2 minus XY, A, M2 minus XY. So M1 is equal to X, M2 over A, M2 minus XY. That's what you're going to write. X, M subscripted 2, A, M subscripted 2 minus XY. Okay, it's not so hard. You've got to think about the fact that M1 is different from M2. They're not the same variable. Those are not exponents. They are separate terms. Okay? And that's going to be your solution. Oh, I'm sorry. I was answering a text. I I feel terrible. I just glanced down and then started typing. Losing my brain. This old age, I'm telling you what. Next problem. So sorry about the radio silence. Responding to a text from a lady at church and totally forgot that I was still recording. So apologies. Stuff happens. Just fast forward over that part if you haven't already. All right, so we're going to use the quadratic formula to solve this, but we've got to get it in the right order, right? So we're going to add x and add 4 to both sides. So that's going to give us 2x squared plus x plus 4 is equal to 0. So then our a is equal to positive 2, our b is equal to positive 1, and our c is equal to a positive 4. So now we can apply the quadratic formula. X is going to be equal to negative 1 plus or minus the square root of 1 squared minus 4 times 2 times 4, 2 times 2. That's our formula. So x is equal to negative 1 plus or minus, and we've got a square root of 1, and then that's going to be 8. Actually, that's going to be 16 times 2. That's going to be 32. So minus 32 over 4. So x is equal to negative 1 plus the square root of 31 over 4, or negative 1 minus the square root of 31 over 4, because you have that plus or minus that's giving you two different answers. You're either adding it on one go and you're subtracting it on the other go. So those are your two answers that would go up here. Negative 1 plus square root of 31. And actually that's negative. And so because it's negative, that would be I, and this would be I. So because it is an I, we reformat that. That's going to be negative 1 over 4 plus square root of 31I over 4. And then negative 1 over 4 minus square root of 31I over 4. That's going to be your two answers. Let me double check that. Okay, so the way it wants you to answer is back up a step. It wants you to answer like this, where x is equal to negative 1 over 4 plus or minus the square root of 31I over 4. So that's what you're going to put in here. This is one blank. This is one blank, right? Like that. So this is negative 1 over 4 plus or minus, and then the fraction 31I over 4. Square root of 31I over 4. That's going to be how you put in your solution. So that's probably very confusing, considering that plus or minus also gives you those two different solutions. This is trying to make sure that you've got, it's going to give you credit if you've got the first term correct, and credit if you get the second term correct. That's what it's doing. It's giving you the opportunity in case you got this part wrong to get half of it right. So that's what the problem is doing. That's why you have two blanks here. It's not so you can do the separate values. It's so you can do individual terms. All right, let's look at the next one. So that is why these were marked incorrect. It's not because you don't have them right. You do. You've got the right answer. It's just it wants it to be the first fraction in the first blank, and then in the second blank, it wants you to do plus or minus square root of 34I over 5. That's what it wants. That's what it's looking for. And then down here, again, you've got the right answer, but it wants you to do negative 7 over 6. And the reason it's doing that is because it wants you, especially when you have that imaginary number in there, we're not supposed to write these as one fraction. They are supposed to be two separate terms without a common denominator. Even though the denominator is the same, we are not supposed to write them together in one fraction. They are supposed to be split up and written separately. So negative 7 is the over 6 is the first term, and the second term is going to be that plus or minus square root of 13 over 6. So break them up. That is the reason why it's doing what it's doing, is because I was seeing a lot of students, and I had to remember why I did that from last year. But that's the reason. These are two separate terms. Even though the denominator is the same, in mathematics, we do not write this in one fraction. If you do it, will people understand what's going on? Yeah, probably. But because a lot of times you end up with this complex term here, with that, we never, ever, ever write the complex term, that imaginary I, in with the other fraction. It's always written separately. You always separate out the complex term because you can't really evaluate it. So we break it down. This we could turn into a decimal. We can't necessarily do a decimal here of any kind. So because of the logic, not the mathematics, not the numeric value, but because of the logic that goes into solving this problem, they have to be two separate terms. This is forcing you to write them as two separate terms in order to get them correct. Okay? All right, I hope that's clearer. You got the math right. Just go back and reformat it and type it in this way, and you'll be fine. All right, that's all I've got. I hope that helps. I will see you Thursday.